Welcome back, student. Now today we'll discuss on domestic electroflux refrigerator or ammonia hydrogen refrigerator. Now, in the previous lecture video, we already discussed on the different types of condenser and evaporator which are basically used in RAC system or in RAC system, or you can say that what is the condenser, actually what is the working principle of condenser, and what is the working principle of evaporator, and what are the types of evaporator mainly used in in RAC unit. Okay, now today we'll discuss on actually domestic electroflux refrigerator, which is usually a VR cycle. It's basically working on VAR, basically vapor absorbent refrigerant. As we know that refrigeration cycle is basically there are two types, VCR and VR. So domestic electroflux refrigerator basically one type of VR cycle, VR type. Now, as we know, the domestic electroflux refrigerator. So this is the block diagram of domestic electroflux refrigerator. Now, first point is that domestic electroflux refrigerator first invented by two Swedish engineer. Okay, two Swedish engineer. That name is Carl Munter and Palton in 1925. Okay, when they are studying in undergraduate course of Royal Institute of Technology in Stockholm. Now, but first ideas were developed by the Electrolux company, Luton at England. Okay, that's why its name is domestic electroflux refrigerator. And now, as you see that this is the block diagram of the, or these are the block diagram of the domestic Electrolux refrigerator. Sorry. So this is the domestic Electrolux refrigerator. Now, in which what you see that mainly there are, what are the components? So one rectifier here, condenser, evaporator, absorber, heat exchanger, and one generator here. Okay. Now, as you see in this diagram, that there are the different parts are there. So what is the main function of all these things we can discuss later, but it's basically three fluid absorbent refrigeration system. Okay, now, so these are the first is generator. As you know, this is a generator, it is a gas burner here. So rectifier, or it sometimes it's called water separator. Condenser, the main function is to condensate or to liquidify from vapor state to liquid state. The evaporator actually refrigerating space, and this is the absorber in which absorb the refrigerant. Okay, and this is the heat exchanger. Heat exchanger main function is to transfer heat from one object to another object. So these are the various parts that a constitute domestic Electrolux refrigerator, and in this system actually main three refrigerant are basically used. That name is NHC1, ammonia, hydrogen, and as well as some water also used. So basically refrigerant which are used as ammonia and hydrogen. So that's why it's called ammonia hydrogen refrigerator. It's sometimes, and it may be it's sometimes called domestic Electrolux refrigerator. Now, as you know that it is basically invented in 1925, and it's sometimes also called that it is a three fluid absorbent system. The three fluid absorbent system means that three fluid which are used, that is basically ammonia, water, and hydrogen. That's why it is called three fluid absorbent refrigerant system. Okay, now actually what is the main purpose of that particular domestic Electrolux refrigerator? That main function or main purpose is to eliminate the pump. Uh, as you know that in VCR cycle or normally VR cycle, there are some parts or some pump devices are there so that it can produce a moving bus, so it can produce a noisy operations. But in case of domestic Electrolux refrigerator, there are no as such pump are basically used. Main purpose is to eliminate the pump so that in absence of moving parts the machine becomes noiseless. So this is the main function of the domestic Electrolux refrigerator, and this is sometimes also called three fluid absorbent system because of mainly three fluid are used, that is ammonia, water, and hydrogen. Okay, now as you know that the main three fluid are basically used, that is basically ammonia, water and hydrogen. Now ammonia as used as a refrigerant, as you know, uh, and because it possesses most of desirable properties of any refrigerant in a domestic Electrolux refrigerator. That's why ammonia is basically used in this case. But as you know that it is toxic, but due to absence of moving part, as it is discussed, that there is no pump as such it is used here, so that is there is absence of moving parts are here, so there is little chance for the leakage, and the total refrigerant leakage of total refrigerant is also is small. So you can use the ammonia as a refrigerant. Now second refrigerant that is used, that is hydrogen. Okay, now hydrogen, as it is lightest gas, hydrogen also it's the lightest gas which is absorbed, which is kept in the evaporator, and it is basically, and why it is used, what is the purpose of that? It is purpose is to increase the rate of evaporation, increase the rate of evaporation of liquid ammonia, of the liquid ammonia which is passing through the evaporator. Okay, now this hydrogen is basically, as you know, there is a non-corrosive in nature and insoluble in water. This is used in the low pressure side of system, because as you know that there are two sides of there is a low pressure side and high pressure side, and hydrogen basically used in the low pressure side of the system. So as you know that, so up to this you can conclude that it's a basically three-fluid absorbent refrigeration system, and its main purpose to eliminate the pump, so that it, in absence of moving parts, the machine becomes noiseless, and the ammonia is used as a refrigerant in domestic Electrolux refrigerator, because of is it possesses all of desirable properties. And second thing is that it is basically toxic in nature, and hydrogen also used as a refrigerant, because it's the lightest it is a lightest gas, and it is the main functions to increase the rate of evaporation and liquid ammonia, which is passing through the evaporator. So this is the basic part. So this is the basic introduction of domestic Electrolux refrigerator. Now what is the working principle of domestic Electrolux refrigerator? Now, as you see in your block diagram, that this is the block diagram of domestic Electrolux refrigerator. What you see here, that first of all, so this is the absorber in which ammonia and hydrogen both refrigerant are absorbed and takes here, and there's a strong solution. Okay, the strong ammonia solution. This strong solution means strong ammonia solution. It's basically from the absorber. It takes from the absorber, which is this absorber. It takes from the absorber and through the heat exchanger. So this is the heat exchanger. Through the heat exchanger is heated to the generator. So this is the generator part. Okay, by applying heat from the external source, and usually a gas burner. Okay, so during this heating process, ammonia vapors are removed from the solution, which is passed to the condenser. Okay, and a rectifier, or it is sometimes also called water separator, fitted before the condenser. This is rectifier is fitted, and the condenser removes water vapor, because rectifier removes the water vapor and carried with the ammonia vapors, so that dry ammonia vapor it's entered into the condenser, because this water vapor, if not removed, will enter into the evaporator. Okay, and this will because this will causing the freezing and choking of the machine. So this is affected portion, this will affect badly in the evaporator. So that's why we use basically rectifier here. Okay, before, when the ammonia vapor is entered into the condenser, there are some rectifier are used, so that the some water vapor or water separator, that can water vapor separate from the ammonia vapor, so that it can enter into the condenser and it reach to the evaporator, so that no choking or no freezing incident takes place. Okay, now that the hot weak solution, that because of when you heat actually the solution which is comes from the absorber, the strong ammonia solution which is comes from the Scottish solution, when you heat, there are some weak solution are there, some hot weak solution are left, which is not passing through the rectifier to the condenser to the evaporator, which is left behind the generator, flows to the refrigerator. Okay, flows to the, so basically this flows through the heat exchanger to the absorber, right, through the heat exchanger. Now when it pass to the when it pass to the heat exchanger, there are some heat gain within the weak solution, and there are some, so there are some heat transfer difference in between weak solution to the strong solution. So this hot solution while passing through the heat exchanger is basically cooled. Now the heat removed by the weak solution is utilized in raising in temperature of strong solution, and and passing through the heat exchanger. In this way actually absorbance is accelerated and improvement in the performance of plant is achieved. Okay, and the ammonia vapors in the condenser are condensed. So the ammonia vapor which is condensed, which, when the ammonia vapor are condensed in the condenser, actually by there are some external agency or external cooling sources are there, that liquid refrigerant leaving, that which liquid refrigerant leaving the condenser, it flows under the gravity due to the evaporator, where it meets the hydrogen gas which is kept in the evaporator, and the hydrogen gas which is being fed to the evaporator permits the liquid ammonia to evaporator at a low pressure and temperature according to the Dalton principle. And during this process of evaporation in the evaporator, the ammonia absorb latent heat from the refrigerator space, and this reduce the, actually this reduce the temperature of the refrigeration space or refrigerator, and this produce actually refrigerant effect or cooling effect. So this is the basic working principle of domestic Electrolux refrigerator. And you can you already know that the in any refrigeration devices, the COP is one important parameter that you can define a particular parameter, that you can define that how it is efficient. So COP is basically, so coefficient of performance of this refrigerator is basically the ratio between the heat absorbed in the evaporator divided by heat supply in the generator. Okay, so this is the domestic Electrolux refrigerator, in which you can see it is basically used. So what is the main function? Main function is to eliminate the pump, so that in absence of moving part the machine becomes noiseless. Okay, so this is the domestic Electrolux refrigerator. So as we can move, now let's take an example or numerical on this topic actually. Now the numerical is that the total pressure in this problem, it is given that the total pressure maintained in an Electrolux refrigerator is 14.71 bar, and the temperature obtained in the evaporator is minus 15 degrees Celsius, and the quantities of heat supplied in the generator are 418.7 kilojoule to dissociate 1 kg of vapor, and 1465.4 kilojoule per kg for increasing the total enthalpy of ammonia. Now the enthalpy of ammonia entering the evaporator is 335 kilojoule per kg. Take the following properties of ammonia at minus 15 degrees Celsius. That properties are: when the ammonia refrigerant enters, that at minus 15 degrees Celsius in the evaporator, that pressure is 2.45 bar, enthalpy of ammonia vapor is 1666 kilojoule per kg, and specific volume is basically 0.5 meter cube per kg. And so the hydrogen enters the evaporator at 25 degrees Celsius, as gas constant for hydrogen is 4.218 kilojoule per kg Kelvin, Cp for hydrogen. And so you have to calculate the COP of this system. Okay, now as you can see this in this problem, though basically the what is given, that the given problem is that in this problem what is given, just go through it first. And the total pressure of this system, it is given, that is 14.71 bar, that is basically PT is your 14.71 bar, and TE basically your the temperature obtained in the evaporator, that is defined as TE, that is minus 15 degrees Celsius, that is nothing but 258 Kelvin, and the quantities of heat supplied in the generator are, that is what amount of heat supplied to the generator to dissociate 1 kg of vapor, that is 418.7 kilojoule, and another type of heat, that is QG2, that 1465.4 kilojoule per kg is given for increasing the total enthalpy of ammonia. So there are two types of heat are added to increase the amount of heat in the generator. So QG1 and QG2, the enthalpy of ammonia entering the evaporator is given as 335 kilojoule per kg. Now different types of 335 kilojoule per kg, that means H1 is given as 335 kilojoule per kg, and the following parameters, that is basically that following parameters of ammonia at minus 15 degrees Celsius, that given as pressure at P2 is equal to 2.45 bar, it is given, and that corresponding enthalpy H2 is basically 1666 kilojoule per kg, and specific volume also given. For hydrogen, the temperature, that is T3, that T3 also it is given. Okay, now T3 also given. Okay, and the value basically it is given that sorry, so T3. Okay, now value of R basically the gas constant for R is for H2 is 4.218 kilojoule per kg Kelvin, and Cp for hydrogen is 12.77 kilojoule per kg Kelvin, it is given. Okay, now we have to find the COB of the system. Now as it is given in this numerical, that total heat Qg is equal to Qg1 plus Qg2, that total heat is equal to 1884 kilojoule per kg. Now total pressure, that is 14.71 bar. Now as you know that in this system, that in the evaporator, the ammonia and hydrogen both represent are there. So the pressure, if the total pressure are given, that means the pressure of ammonia and pressure of hydrogen is given. So Pt is equal to P2 plus pH2. So as you know that P2 is your given, so NH3 that is given 2.545 bar. So how do you calculate pH2? Because of P2, Pt means total pressure is equal to ammonia pressure plus hydrogen pressure. So hydrogen pressure is equal to total pressure minus hydrogen pressure, ammonia pressure. So that will be 12.26 bar. Okay, if you convert into bar to Newton per meter square, so 12.26 into 10 to the power 5 Newton per meter square. Now in this and now for figure for ammonia, the value is given that H1 is equal to 335 kilojoule per kg, 335 kilojoule per kg, and H2 is equal to, it is given that for pressure at minus 15 degrees Celsius, H2 is equal to 1666 kilojoule per kg. Okay, now actually you have to calculate the COP. Okay, now so suppose this is your evaporator. In these sections, the liquid ammonia enters into the evaporator, and this is the strong ammonia solutions. As you see in this diagram, suppose this is your evaporator section. So this is the evaporator section. Now what is here, that this is an absorber. Okay, that means if you connect, so ammonia, liquid ammonia, that is NH3, so that is for 1 kg if added in the evaporator. Now absorbent is a hydrogen also m kg, total ammonia and hydrogen will be 1 plus m kg, right? So this is the figure for ammonia. So suppose this is the evaporator in which ammonia, that is, suppose we are assume that 1 kg of ammonia is mixed when the hydrogen is with m kg. So after mixing together, the total refrigerant will be ammonia, hydrogen will be 1 kg plus m kg, right? So let m kg of hydrogen flow through the evaporator. So let the m kg of refrigerant hydrogen flow to the evaporator, and per kg of ammonia. Okay, so ammonia occupies the volume, that is 0.5 meter cube per kg. It is given in numerical. So this is the same is the volume of hydrogen at T is equal to minus 15 degrees Celsius? Because the evaporator temperature at minus 15 degrees, that means ammonia and hydrogen both occupies at temperature T is equal to minus 15 degrees Celsius, that is basically 258 Kelvin. So the amount of hydrogen mixed for in this case, so that will be M, as it is a hydrogen is as is ideal gas, so it is follows the PV is equal to MRT. From that equation you can calculate M is equal to pH2 into V divided by R into T. So pH2, that means the pressure, the value is 1226. Okay, so the pressure is 1226 into 0.52. This is a specific volume. R value is given and T value is also given, so the M will be 0.5633 kg. Now when you calculate the first, as you know, the COP is the ratio between the QE by QG. Okay, QE by QG. Now considering the energy balance, consider the energy balance for evaporator as it is shown in your diagram. So for the energy balance for the evaporator, that will be 1, that we assume that 1 kg of ammonia, that will be 1. So the net energy balance will be H2 minus H1 and is equal to Cp into M. So Cp into M into T3 minus T2 plus of QE. Okay, so this is the main energy balance equation. Put all these values in terms of H2, H1, Cp and M and T3 and T2, and you can get the value of QE here. So QE will be equal to 1043 kilojoule per kg of ammonia. Now COP, as you know, that COP is the ratio between QE by QG. So as Cp is equal to COP is equal to QE by QG, so put all this value QE and by QG. So 1043 divided by 1884.1. So the COP will be 0.5536. The net COP will be 0.5536. Okay, so this is the answer that you can get from this numerical. Now let us take a quiz on electroflux refrigerator. Now an electroflux refrigerator, you just try yourself. An electroflux refrigerator is a VCR, first option. Second option is that vapor absorbent refrigerant with a liquid. Third option, with a liquid pump. Third option, vapor absorbent refrigerant without any pump, and none of this. So what is your answer? So think about it. I think all of you get it. So the answer will be the vapor absorbent refrigerant system, as we discussed, without any pump, because of main purpose is to for Electrolux refrigerator is that Electrolux refrigerator is that there is no as such moving parts are there and pump is not used in there, so that there are machine operation is noiseless. So the option C will be correct for this case. Now we'll take another MCQ or quiz on second one. The second one is that electroflux refrigerator is called a, just try yourself, single fluid absorbent refrigeration system, 2 fluid absorbent refrigeration system, 3 fluid absorbent refrigeration, none of this. Which one is correct? I think all of you get it now. So the answer will be 3 fluid absorbent system. Because of ammonia, water and hydrogen, 3 types of refrigerant are used. That's why it is called 3 fluid absorbent refrigeration system. And the last quiz question is that hydrogen is used in Electrolux refrigerator system so as to dash the vapor pressure ammonia in the evaporator. The answer is, which one is right? So option B is your right answer, that reduce the vapor pressure ammonia in the evaporator. Okay, thank you very much for listening and watching me, and thank you. But in the next lecture video we can discuss on lithium bromide absorbent refrigeration system. Okay, thank you very much for listening me and watching me. Goodbye.